Hey everybody, this is Larry. This is me going over Q3 of the weekly contest 295, steps to make array non-decreasing. So this is the trickiest part of the contest for me and also a lot of people. You can see a lot of people took a long time here. I actually, if you watch and as part of this video, you can get to see me solve this problem live later on, and yeah, you could see that I actually spent about 10 minutes debugging, but that still means that this was a 20-minute problem for me. Mostly because I misunderstood how to. I think I was trying to be too clever and kind of implement something better. But to be honest, this was not that bad of a problem if you know how to approach it correctly. I'm going to go over my solution, and I spent a lot of time debugging because I missed one case on how I thought about it. But if I did it, I think I'm going to do something funky for this one where I live upsolve this one, and I'll talk about it in a second. Hit the like button, hit the subscribe button, join my Discord, and yeah, let's chat about this problem. Give me some love, and yeah, let's see how many is like steps to make Larry's rating non-decreasing. Am I right? Because it's been decreasing the entire time. So hopefully your rating is not non-decreasing too. But yeah, let's go over the way that I did it. But and the idea that I do, I actually did it brute force. I have some brute force code here just for kind of checking my answers because I knew that this was going to be too slow because n is 10 to the 5th. Each iteration could, like, if you get you remove one item every time, that's going to be n squared. So that's definitely too slow. But I used it to check one of the answers. So now I'm going to delete it. But the basic idea, one core part of the idea is noting that you have these points where you have a number and it is bigger than the number next to it, and then now when you remove this number, this 5 is still there and it could still be bigger than the number next to it. So that's basically the idea, meaning that you don't have to check every number, you just have to check I don't know how to call it, like the peak maybe. I don't know if that's peak, but a cliff. Let's call these things cliff, right? So you just have to check the cliffs every time, and once a cliff gets removed or it stops being a cliff, then you no longer need to care for it. And so the complexity here is good because for each cliff, every iteration will remove at least one number. So that means that it's amortized linear time in total of iterations because once it stops removing a number and each number can only be removed once, there was no more cliff. So that's basically the idea I have here. I use sorted lists for a reason. I don't know that I like this, but it works. So yeah, so I have a sorted list where I keep track of the index and the number, and this way I can do a binary search. The reason is that I can do a binary search on the index and then look at the number next to it to see whether I could have done this another way. Actually, now that I noticed this, I could have just binary search for the index, and then this is just index plus 1. I don't know why I did it this way. Well, if you see how I did it, you'll see how I evolved it. But yeah, but basically I keep track of that, and like I said, let's say pairs or the cliffs. So if I look at adjacent pairs, these are the critical points that we care about. And while the critical points are greater than 0, we see if there's any removal. And like I said, we binary search for the index. For the index, we make sure that it's still in the array. This 3 lines of code actually took me like 10 minutes to debug because I was just doing it a little bit off. And then and this is just C index plus 1, to be honest, but didn't know that at the time. And then we just make sure that basically these are 2 adjacent elements, given that this is the element that we care about, the critical point or the cliff. And here we just check if it's still bigger than if it's bigger than the adjacent element, then we remove it and we still care about it as a cliff. And then we just keep track of things and increment step. So yeah, so as you can see, for each number, each cliff, it's going to take log n time. And as I said, amortized, each number can only be removed once. So the number of total cliffs is going to be linear time because or linear number of cliffs, because each cliff will have a number that is to be removed, and there, you can only remove n numbers, right? So that means that the total time complexity is O of n. Oh, sorry, time is number of loops is O of n. Each removal is O of log n. So total time is O of n log n. And of course, space is also O of n for that reason. O of n for sorted list, and care only, cliff can only contain items that contains element to be removed. And of course, like I said, the same logic before, each item can only be removed once. So so there's only going to be n number of things ever queued up. Yeah, so that's basically the idea here, right? The other thing that I would do, and I'm going to try to do this live in this video, and there is time space solution, and well, let me just actually show this real quick so you could all see it. So if you want to care for it, here, this is my code, roughly speaking. I mean, I believe you can see this, right? Yeah, and then now I'm gonna erase this to, let's say, solve this again. And there is a better solution, which is why I think this is a Q3, though I think people that are doing these problems might not. I actually did figure this out during the contest, but I was just a little bit, like, I was, one of those things where you always set on a solution, you didn't want to rewrite it. Maybe I could have, because I think in retrospect, debugging taking 10 minutes and even 2 wrong answers, if I just did it the other way to begin with, it would be much, like, it would take lower penalty or lower time. So the trick here, or the observation here, is just linked list, because you have to remove nearby items, right? So yeah, let's so let's live solve with me explaining how to do this. So now we declare a linked list node. We have a thing, yeah, and solve.next is equal to none, right? Yeah, and then now let's say we have head is equal to node of -1. It is what it is. And then now for x in nums, and we have a current is equal to head. And then now we have a node of x, current.next is equal to this, and then current is equal to current.next, right? So then now we have a linked list. This is, if you have done enough Leetcode problems, and I hope that you have, or if you haven't, it's fine. But there are a lot of linked list problems that are specifically linked list, but this one is one of those rare ones where this is more useful, right? And then now it's the same idea. We have a, let's just say we have a removed, we can make it a set to keep it a little bit more fun. Yeah, keep it a set. And then also, oh yeah, and a care thing that we talked about. We can have this as a set as well in this case, but it doesn't really matter. Yeah, so then now, of course, current is equal to head again, and then now we do something like while current or head.next to get the is not none, right? Current is equal to current.next, and then initially we'll just have care.add. I don't know how these things work, but yeah, current, if current.next is not none, and current.value is greater than current.next.value, then we care about this value, right? And then now we can just do, yeah, steps is equal to 0, while length of care is greater than 0. We Yeah, maybe. I mean, we'll see how this shakes out. But this is the general idea, and it's the same idea as before, but now you know exactly where things are. But basically, yeah. So for node in care, if node, and let's say n care for next care, as I always say, if node, how do we don't even need to do removed, I suppose, but maybe that's a little bit better. I'm just thinking about optimization, but let's keep it simple, right? If node.next is not none and node.value is greater than node.next.value, then, well, in the future, we have to care about it. Node, but we also want to add removed is, we want to add node.next to the remove. And we also want to do node is equal to, or node.next is equal to node.next.next, right? And this is just standard linked list removal stuff. And then now we can do if length of n care is greater than 0, then steps. Yeah, maybe this is a little bit cleaner. Basically, yeah, and then we can now do care is equal to n care. I think this is roughly. Oh, we have to check removal. Whoops, sorry. Yeah, so. Yeah, so if node is not in removed, because if it's in removed, then we don't care about it, or like we can skip ahead in the caring section, so that you don't kind of do it that way. But yeah, this is pretty, this is the same idea we've talked about. You just have to convert it to linked list, and let's give it some, I don't have the examples that we had before, so let's just give it a submit. This is still doing contest, so we'll see if this works. Maybe there's a wrong answer. We'll see. Oh, yikes. Hope that doesn't add to my penalty. That'll be funny, though. Because I think this is okay. But output is 2, but this is 1. Why? Tell me why. 2, 6, and 5. Oh, it's a little bit sloppy on my hand. Because we're going from left to right, we remove the node before we do it. So I think that's why we. Yeah, okay. So we just need a new removal, or remove this equal to set. You go to set, and then we add it to the next removal. And then now we moved for x for node and removed. Removed add node, right? So this is just because if you're going from left to right, it thinks it just removes multiple times because it took twice because it removed 6, even though it should remove 6 and 5 in the same iteration, it removed the 6 and then, so maybe I would still get a wrong answer because I rushed it this time. Kind of surprised. I was gonna say it's surprising that didn't show up here, but I think it just got dominated by the prices. Yeah, let's give it another submit, and hopefully this is a little bit better. Otherwise, this is just embarrassing. Didn't we run this? I don't get it. Why is this output 2 when? Huh? I am really confused because we submitted, right? Is this the same code? Yeah. Like, why is this? This is 1, right? Why this gives me the wrong answer again? Is this the wrong answer again? Why? Okay. Well, to be honest, I don't know why this is giving me the wrong answer, but that's really weird actually. Because as you can see, we run the code. This is giving me 1, but if we run the code here, it's giving me 2. Do we have some like weird? Yeah, I don't know. Okay, I mean, look, I don't know if there's some bug in the system. Um, maybe there's something weird with the hash code or something. I don't know. I think that was the problem that I was thinking about. So maybe the hash code is a little bit weird or something. Um, I don't know. Yeah, maybe because the next change it hashes a little bit differently. I think that may be a thing. To be honest, it's something that I worried about. I think one thing that we can do here is actually instead of removing and having this, I guess there are like weirdness about it. But uh, okay. I mean, I'm not going to spend that much time debugging this. I think. Um, Something like that maybe, and then instead you could have. I think this actually has the same issue that we had earlier. Um, oh, this is that. I think this is what happens. Well, the thing is, this is what I should have done. Okay. Um, yeah, I think the care thing is a little bit weird, but anyway, I guess there's some weirdness where, because yeah, like it's giving me one, but for some reason when I put it, this is the same one, right? Like I'm not just pasting the wrong thing. No. Okay, let's give it one more submit and just to see. Yeah. Okay. Fine. Um, that was a little bit silly actually. That'd be funny if this ends up being a lot of penalty in the future. This may still be wrong answer because of the way that we did it. Yeah. I mean that's fine, but I was just very weird that like this one was giving me the wrong answer, and some of this is like what we said with respect to the timing and the order of the removal. So maybe this should be a list, and then now we want to reverse this, and this is a list as well, and then yeah, and then here we want to reverse it back. Add append. I probably would have been more careful during the contest, but there's a lot of random weird things here, to be honest. I don't know. But anyway, this is the idea that I think I would recommend doing. Let's see. So apparently, I still have. There you go, accepted. But so I think this is the cleanest solution. This is the solution I think that is intended. And if you had done, I wanted to say that this would have been much faster and cleaner, but clearly I have a lot of random issues here, but I actually thought about. I knew that I wanted to do this because that's how I did it in my original self. But I was trying to be more precise. But there's some weird thing with. I think the reason is because yeah, the hashing is just a little bit weird, maybe with respect to the next or something, because we changed the value or something. I don't know, could be wrong there, but still, this is what I recommend. And of course, all this is O of one, so everything is going to be O of n time and O of n space. I think this is the better clean solution, even though it took me like 5 attempts, so maybe it would have been more expensive. But that's really awkward in general. Well, some of them were just me being lazy, like this one time error and this other wrong answer. But I think this one should have been okay, or maybe the second one. I think I didn't do that in the right order. I probably could have been more mindful, but I just wanted to focus on it. Hopefully it doesn't. It will be funny if it pops up. But yeah, that'll be funny if the other solution times out, and well, it is what it is. But cool. That's pretty much all I have for this one. How many people have gotten it? 200 people got it. But yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy to good mental health. You could watch me self live in contest now. Okay. Oh, wait a minute. in one step, all elements. Can we do this in good time? Okay. No, I don't need a stack. Yeah, okay. Non-decreasing, okay, so if x is greater than y, then we one else. Oh no, that's why I needed a stack. Okay, fine. The last number is smaller than the number before that. Someone like that. A little bit slow on this one. Let's give it a minute. Not 100% sure about this one. Oh man. Maybe I don't understand this one. Oh. Okay. Huh. I did not understand this one that well. Okay. How do you do it? I rushed this one a little bit. Could I have done it in 5 minutes? I don't know. The penalty, is it worth it? That's basically so I was trying to do a longest thing, but that's clearly not working. Let me see. How do I think about this? Because you can't simulate. Can you simulate? How do you? I guess you would do a linked list type thing, but yeah, okay, fine. Yeah. Okay. So now let's just say what a silly 5-minute penalty. People get it. A lot of people got it wrong, so maybe not just me at least. No, I know how to do it though, but still a 5-minute penalty. Also, yeah, okay. I mean, I refreshed, so I lost that other one, but okay. greater than num sub I 1 q.append I. Okay, and then now basically okay, x q is equal to but basically for I in care, if num sub I is greater than next sub I, this should be I plus 1, then next sub I is equal to the next number no next sub I think. Okay, okay. Oh, whoops, I meant this is minus 1. Whoops, that one's an easy thing to fix. This may time out, but no, this is okay. Huh. Oh, of course, I'm silly. Okay, that's not what I expected, but oh, 4, 7, 8. What do you do on decreasing sequence? It doesn't tell. I wish they had one example. Okay, 11, 8, 5 is a good one. Okay, so you remove those two. That's a little bit awkward actually. So then basically you remove those. Okay. No, 0478 is what we care about. Oh, whoops. Yeah, I have to reverse it twice anyway. Okay, 0478. Yeah. People get it yet? Wow, people are already done. But only 2 people got it. So maybe Q4 is easier, it seems like. But what we want is, okay, so 7, 8. So 9 should already be skipped. So 8 should already point to 10. Why not? Okay, this is because this is this. Yeah, okay. Yeah, okay. This is good. Okay, so this is still wrong, but oh well. Okay, so this, and then now the next iteration. Why? So 8 is skipped. That's fine. So then now the next number is 10, which is fine. think this is a little bit confusing. Let's do it in a little bit differently. Okay, let's say we care about this. Okay, and then now we say this may be a little bit slow, we'll see. So while for each care, if x is equal to nums dot bisect right of I, this bisect left is fine. Okay, so something like that. Okay. Otherwise, num sub index next index and value is equal to so then if num sub I is greater than v, this is actually wrong, is SL. Then we want to remove so that we remove cherry. And then we have to check again next time. Okay, maybe this is better. Care, I don't care. Do. Okay, line 901. Huh? Isn't that the definition of? Oh, this is length of SL because we can get smaller. Okay, 4, 0, and 7. That's not good. Is my algorithm wrong? Should be. Why? Tell me why. Do. Tell me why. Okay, you move 1 5. Okay. Oh, that's fair. I guess that's true actually. I think this is right. It just sees to see if it's care. If length of n care is okay. I think this should be here, to be honest. I think that's why it's a little bit wrong. That true? Oh, this is a check. Okay, fine. Alright, let's hope this is fast enough. Oh wow, it's not right enough. Okay, Let's see. This should be 7, but expected is 10. Why? Is it possible to have an increasing thing? I don't know. I think the idea should be right, but maybe I'm a little bit too whatever. I should have skipped ahead, but so 0. Okay, let's see. Let's print SL so we could see what, like, it's there maybe still So this is good in the sorted list. Am I too aggressive in removing stuff? Is that why? Oh, I have to check whether this is I is removed. Maybe that's why. Okay. Let's see. Index if I -1 if continue. Okay. Still not true. Why does this take 10 steps? Okay, I guess I have to write a brute force one. Let's see. A is B is equal to do for I going to length A if we moved I B dot append A sub I A is equal to B this is yeah, okay. If length of B is equal to length of A, we break. Okay. Okay. Would I not increment? I mean, this is just awkward. Okay, so this is just off force. Why? Oh, oops. I am just a dummy, turns out. I can't even do the brute force, right? Okay, 1, 2, 3, 4, 5, 7, 8, 9, 10, at least, something like that. Oh, man. Like maybe I do 11, but okay, so 10 is definitely right, but, okay. How many people got it? More people got it, but it seems like Q4 is way more straightforward. Okay. and remove all this. So technically, let's just say care. So this is essentially the same as care step, right? So yeah, this spot is good. But then now, what is this? Oh, the indexes are different, but that's fine, I think. Why is this different? So this, and then this, and then, but the third step is less, that's why. But why? Okay, let's see. Let's print v num sub I v. I really don't know, to be honest. Okay. This is a lot of processing data. Okay, so you have this thing, and then there's too many things. All right, let's just take that out real quick. And then now, the third removal is 5. Seems right. Why did I stop so quickly? Oh. Maybe I need to print this at every step instead. The removal is a little bit confusing, maybe. Okay, let's say SL, and then here I print A instead. Maybe. I don't know if this is quite right. This is A is after removal. Okay, fine. Okay, so do we this to make it clearer? Okay. I didn't print the one with removal. Okay, let's see. So it goes. Okay, so this is mostly right. Maybe. First step is right. The second step. How come it? Well, this is weird. Actually, there are a couple of steps where it doesn't do anything on my thing, so that's already something that's wrong. Oh, that's a little bit awkward because if it doesn't, maybe I need to do this because I think there's a thing where it deletes, but still though. Why is this wrong? Okay, so we have this. In the third step, it is right. Fourth step, maybe is right. This is already weird. Is this way? No, I already removed too much, I think. Like I removed all these things already somehow. Even though this is increasing. So, okay. Wow, this is a tricky one. Okay, so okay, how do I do this? How do I trace one number? So 1842. 1842. Okay, 19 is fine, 19 is here. And then we remove 18 and 19 at the same time, and that is not right on this step. That is just too much. Why? Okay, let's put step n down here. Okay, so 9. Care about 9, but 12. We also care about 12 somehow. Oh, I see. So it got removed, but where's that code? Okay, so if it's not, then we'll see index I2 it should be okay. But if I2 is not equal to I, continue. Is that better? That would be a silly mistake. Yeah, okay. I have to comment out a lot of print statements. Actually, I should just comment this entire thing out, but yeah. Yeah, let's see. Okay, and then here. Okay, let's give it a submit again. That'll be funny now with time limits after all the debugging. Okay, cool. That was a great. Hey, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, give me some love and support. Yeah, stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.